Hey, I wanted to discuss the three main triangles used in doing trigonometric substitutions. We've already gone through one with the intro and an example, and that was the square root of a squared minus x squared. So this is where under our square root we have a number minus a variable squared. If we do that, we usually make that the adjacent side. Okay, so with that being the adjacent side, the opposite side of our angle is x and our hypotenuse is a. So just to kind of narrow everything down here, that puts the fact that the two main substitutions we're looking at is that we can use the sine is the opposite over hypotenuse, x over a, and the cosine is adjacent over hypotenuse, which is square root of x squared minus, square root of a squared minus x squared all over a. And those two substitutions follow everything else that you will need. But keep in mind, this is the setup you want when you have number minus a square variable. Then we have a different situation here where the roles are reversed. Square root of x squared minus a squared. So now it's the variable minus the number. And remember, the order of subtraction is important. You change the order of subtraction, you change the value. So in that case, the setup we're going to have is across from our angle, we'll have the square root, x squared minus a squared. We'll make the adjacent a and the hypotenuse x. So the substitution that works good there is secant equals x over a. That is hypotenuse over adjacent. It's reciprocal of the cosine. And then the tangent will be the opposite over adjacent. That's the square root of x squared minus a squared all over a. And if you follow with the differentials and manipulate, these will work out for you. We're going to do some examples, don't worry. And then lastly, the only other option you have is if you are adding under here. So square root of a squared plus x squared. The order of addition doesn't matter, so that could be square root of x squared plus a squared, but that's the hypotenuse. So that's the hypotenuse, and then we'll use for the opposite x and the adjacent a. And the substitution we'll make is tangent equals opposite over adjacent, that's x over a. And secant will be hypotenuse over adjacent, so that's the square root factor over a. And those are the three triangles that come from the setup of a trig substitution, and which one you should pick based upon how your square root looks or how your two squares are interacting with each other.